Okay. Now, I did that last problem with a right triangle.
Yeah.
Okay? We could also do that very same problem, but use ordered pairs instead. Okay? We could do that very same problem using ordered pairs. Okay? The person is trying to swim at this vector, -5, 0. Because if we draw our coordinate plane, the person is trying to swim -5, 0. You guys see that?
Yeah.
Person is trying to swim at -5, 0. The river is doing what? Pushing him at what? 0, -2. So really, all you're doing is adding those two vectors together. -5, 0 plus 0, -2 ends up equaling what? -5, -2. Draw your picture, -5, -2. Find your magnitude, find your direction. Okay? This is called solving problems using vertical and horizontal components and adding them together. Some of you will like this method for the more complicated ones, especially when we start adding 3 vectors together. You will want to change everything to horizontal and vertical components and then add all those together before you do your problem at the end, before you find the magnitude and direction at the end. Okay? So you can do x, y, x, y, and add the x's together, add the y's together to draw your final answer as well. You guys understand what I'm saying there?
Well, wouldn't you, if you're adding 3, wouldn't it have to be like x, y, z?
No, 3 different vectors, 3 different
Yeah.
forces. So you have
So it's
x1, y1, x2, y2, x3, y3. So you add all 3 x's together, add all 3 y's together.
That's not hard. So,
All right? Let's see. Next problem. Let's say vector B is 4, -3. Okay, I'm going to switch to the other board here and do this problem in a second. Let's say vector B is 4, -3. And vector C is 2, 7. Then find vector A if A is equal to B plus C.
Oh,
So A was what? 4, -3.
No, that was
No,
B.
B. A is equal to B plus C.
we have to find the.
So vector B was 4, -3.
Yeah.
Vector C,
2, 7.
2, 7. Huh?
In the problem, it shows my coordinates.
Because I can't do the pointed things when I'm typing in my Google Calendar notes. So, no, that's
Is that a B?
the way to notice it. So vector B is 4, -3. Vector C is 2, 7. And we said vector A is the resultant of B plus C. This is very simple. add your x's together, add your y's together. So vector A will equal what? 6, 4. Okay? You can just add your x's, add your y's.
And then Pythagorean's theorem.
No, I didn't even ask for that, but yeah, if I said now find the magnitude and direction of vector A, yeah, draw your, just like the problem basically I gave you at the beginning of class. Here's your answer. Draw the picture, do Pythagoreans to find the magnitude, do inverse tangent to find the direction. Okay? But all it did was say find vector A, or write vector A as an ordered pair. Okay? Easy enough there? Opposite vectors. Okay? Opposite vectors. If vector B is 4, -3, what's the opposite of vector B? -4, 3. What's the opposite of vector C? -2, -7. The opposite, you just change the x and y values to their opposites. Okay? So, if I said to take vector B and subtract vector C, by subtracting a vector, it just means you're doing that vector in the exact opposite direction, or you're doing the opposite of that vector. So really it's like, instead of subtracting, you add its opposite, and really if you go back all the way to when you first learned how to work with positives and negatives, okay? So really this is saying, take vector B plus the opposite of vector C. You can't. They're both okay.
Would you have to flip vector B then too?
No.
No, it's just subtracting.
So vector B was what?
4, -3.
4, -3 plus the opposite of vector C. Well, the opposite of vector C is -2, -7. Or yes, you could just keep it as subtraction. All right? In vectors, we don't really take away a force. Okay, if you think about it, you can't subtract a force. That's not really, it's an opposite force, and that's really why this is a little more correct. Subtraction still works when you're working with ordered pairs, but if I said, you know, the chair thing, okay, we're going to apply this force, and then we're going to apply the opposite of that force, or subtract that force, doesn't mean you take it away, it just means that it's going to be going the exact opposite direction. Okay? What would our answer be? 2, -10. Okay? 2, -10. All right? Scalar multiplication. Let's say you were asked to do this.
You just distribute them.
Yep. 4 times vector B, basically you're going to take vector B and give it 4 times its strength, or 4 times its force. All right? Well, vector B was just 4, -3, but now we're quadrupling that force. We're multiplying it by 4, okay? So really, 4 of vector B now, 4 of those, think 4 of those pictures, 4 of those vectors drawn out, would be 16, -12. plus negative 2 vector c. So in other words, plus c's opposite twice.
14.
So that'd be
So
plus,
negative 2 plus.
instead of 2, 7, it'll be what? Negative 4, negative 14? Not sure what happened there. Negative 4, negative 14, answer
12, negative 26.
12, negative 26.
Said -4, -14.
Yes. Now visually what that would look like, vector B was 4, negative 3, right? Okay, watch this. Okay, 4, negative 3 would be a vector that's going right and down, correct?
Yes.
4, negative 3, this is kind of important here. But I'm doing 4 of those vectors, so it'd be like I'm doing this. 1b, 2b, 3b, 4b. So there's 4 of my vector b's. And then from there, okay, I'm going to draw kind of a new coordinate plane here. From there, I'm doing the opposite of vector c twice. Well, vector c was 2, 7, so vector c was up and to the right. But now I'm doing the opposite of that, so instead of going up and to the right, I'd be going down and to the left. So vector c, vector c. So there's my 1, 2, 3, 4b. There's my negative 1c, negative 2c. So then this right here, that red vector, is that. That red vector from where it starts to where it ended up went 12, negative 26. Obviously not to scale. I didn't have the room to go 12, negative 26 there. Okay? But that's really what's going on visually. Okay? Pause. I get over 15.